Hey guys, so this is the amplifier module off the powered mixer, yeah, and I've now managed to remove the nuts on here. I managed to get a tool that would actually fit in there and take them off. So this is what we have. Yesterday I was slightly confused myself, and maybe a few of you who realised I was wrong, and I was to some extent right and wrong. So this is a Class G amplifier, yeah, and I thought initially that effectively this was like the negative and the positive half of the amplifier, you know, the complementary. So one side handles the positive half of the waveform and the other one's the negative half of the waveform. But I realised, actually, looking a bit closer, that's actually not the case. That's not exactly what we have here. Let me zoom the camera down a little bit and I'll show you. So if you look, these are the two boards, yeah. The first thing you'll notice is they're not the same, yeah. This one's a lot more chunky, it has a lot more heavy components in than this one, yeah, like these big resistors, big inductor here, which this doesn't have, yeah. This has a couple of devices here, which I said, oh, that's probably the thing that switches the voltage rails on the Class G amplifier between high and low. But that's actually not what we have. If you look on this one, we have two output devices, MJ5003, yeah, and two MJ5004, and these are the ones that are short. These parts, 003, 004, these will be what's called a complementary pair. They could be bipolar transistors, they could be MOSFETs. I'll have a look shortly and we'll see what they actually are, yeah. So effectively you'll have like an N-type and a P-type basically, yeah? And this is the side that's short circuit on this one, yeah? So when I say N-type or P-type, if they're MOSFETs, these could be like N-channel and P-channel or vice versa, yeah? If they are bipolar, they'll be NPN and PNP. But they're complementary in as much as, apart from like the difference of the P-type and N-type, they have the same ratings. So the voltage, maximum voltage, the maximum current, the maximum wattage, the base turn-on voltage or gate turn-on voltage of these will match these. So they're matching, but like a mirror. One's a mirror of the other, positive and negative, and that's called a complementary pair. So we have on here effectively an entire complementary circuit, yeah? On here, this one you'll see we have different devices. So MJ15003, two of them, and MJ15002, or is it 002? Yeah, 15022 and 15023. Again, these will be complementary pairs. So same voltage and current, sensitivity ratings and everything. Just one's the positive and one's the negative, like the mirror of each other again, yeah. So which of these boards is actually doing what and why are they different? Well, let's have a look at that Class G amplifier again, and then we'll figure out what we've actually got here, yeah? So, Class G amplifier. I'll draw it again. Let me just zoom out a little bit. We basically have this. So, we have an amplifier. I'll draw this with bipolar transistors, but they could just as easily be FETs. The same principle would apply, just the biasing would be different basically, yeah. So this is the NPN, yeah, and this is your PNP, yeah. It's the base coming in. So this is your positive supply, yeah, and this is your negative supply, yeah. Put some bias resistors in here, why not? Some sort of bias network, yeah. It won't connect like that, there must be capacitors here. Something like that, yeah. So this is in, this is the ground, yeah. And then these capacitors would stop any DC getting down these either side, yeah. You only want the AC signal to go into your amplifier, yeah. And from here, loudspeaker, to ground. Okay, so that's basically what we have as an amplifier. Okay, now we need to change the voltage on here to switch between effectively high power and low power. So we know we have a 44 volt supply, yeah, plus minus, and we also have an 88 volt supply, yeah. So we have 88 volts plus 88 volts minus, yeah. There you go. And here we effectively have some FETs, yeah. Gate, yeah. And we have a FET. Gate, yeah. And these again will be complementary, so there'll be a P-type and an N-type, same as like the PNP and an NPN, yeah. So you have a P-type and an N-type, yeah. I think I've drawn them the right way around. Okay, so this FET goes here. The diode is so it can only pass voltage in one direction, because when this is turned on, this is plus 88, yeah. When it's turned off, it can't conduct from the 44 back that way. Sorry, minus. This is your minus rail. Yeah. So the diode is going to be the other way around. Yeah. I think. Yeah. Other way around. Okay. And then here again we have diode to there. Yeah. So effectively, you can turn these two FETs on. Yeah, when you want to have a higher voltage supply to these. So under normal power, this has a plus or minus 44 volts. That effectively limits the amount of heat that these transistors are generating to the heatsink, the amount of heat they're wasting, yeah? Speaker in here. But you want to drive audio, and the more audio you want, the higher the wattage you want, yeah? Watts equals voltage times current, yeah? Okay. So for a certain voltage supply, yeah, plus or minus 40, so it's got a 40 volt supply on this speaker, yeah. So it's 4 ohms, yeah. So for a 40 volt supply, you can work out what the maximum wattage effectively this is. This might not be exactly right because we're talking about AC signals, and I'm just going to work it out on DC. So it may not actually, this won't actually be exactly correct, but the principle's okay, yeah. So if you want to know what the maximum wattage is, yeah, voltage IR, this is Ohm's law, VIR, yeah, so we want to know the current. Current is V over R, that's why we draw it like a triangle, yeah. I equals V over R, which roughly is 40 over 4 equals 10 amps, yeah. So the highest current could flow would be 10 amps, yeah. Wattage is voltage times current, yeah. 40 times 10 equals 400, yeah. That's a DC wattage. You have to divide that by I think 0.6 or roughly to get it into AC. But we're not going to do any maths on this channel. We're just going to prove a point, yeah. So if you want to get more wattage out of the speaker, you need a higher voltage supply. But in doing so, these transistors dissipate more heat. So that's why we have this sort of circuit. So we don't have the high voltage supply there all the time. We only have the high voltage supply here when we need it, yeah. When we need it, when there's a peak in the music, when the music amplitude goes above effectively the maximum point that 44 volts could handle, yeah. So when it goes above that, we have to increase the voltage supply to the amplifier so it can handle this part of the waveform. Otherwise what would happen is you'd effectively chop it off, which is bad distortion and not good for your speakers, yeah, because it can't go more or less than 44 volts. So that's why we switch the voltage so it can go to plus or minus 88 volts, yeah. And by not having the 88 volts there all the time improves the efficiency of the amplifier. That's basically what it is. It means you can make a smaller, lighter amplifier with smaller heat sinks, less cooling fans, more efficient, yeah. Effectively, although you got the cost of components, you could say cheaper to make in the weight, especially, you know, big heavy heat sinks. But it makes the circuit more complicated. So that's what we have, yeah. And we can kind of see this on our circuit board. So this is the lighter of the two, yeah. And I'm confident this one is effectively these FETs. Only on our board, because of the high current rating, yeah. We have another FET connected across there in parallel, yeah. And we have another FET connected across here. In parallel, yeah. And the same with these. We have two pairs of these again in parallel, yeah. Just to handle the power rating. So there's another one there, and there's another one NPN here, yeah. Yeah. So there's two, yeah. Two, yeah. These. Two, these. Complementary. P-type, N-type on both. Reason I know this is the amplifier, by the way, in particular, is because it says down here, yeah, output. Output. But there's another reason I know this is the amplifier. Let's look at this one. So coming in, we've got minus HV, yeah, where it says black, minus high voltage, and on the blue, minus low voltage, yeah. On this one, plus high voltage, plus low voltage, yeah. And these have a short, yeah. If you look, these FETs connect to the high voltage. So effectively, high voltage comes in here, yeah. This is the minus one, and goes directly to these output devices here, yeah. This is the one that's actually short, okay, and this one. So that's your high voltage supply, negative. High voltage positive, red, comes in here, to these devices, yeah, and these are not short. So that's those two coming in, yeah, red and black. The other two then, the blue and the violet, this is the low voltage, positive, negative, yeah, positive violet, negative. And if you look where these go, you'll see the negative one actually goes to this device here, yeah, and this, the other side of this is a diode. I'll put it on diode range, you'll probably see it. You may not because of the short on this, but yeah, diode junction, yeah. And if you look at the other one coming in, the violet one, you'll find that it goes to the other diode. That's these two diodes here, yeah, these are diodes. It goes to this one, yeah, diode junction, yeah. So those go to these two diodes. That's effectively this and these diodes, yeah. And after the diodes, they go to these wires. So here we have red and black, and these are going to the amplifier board, yeah, and green, which is 0 volts, okay. And if you look at the red and black, one of them comes from this diode, yeah, and the other one comes from this diode. Is it black? There. The other one comes from this diode, yeah. So that's your red and black wires coming in. The output of the devices effectively also go to here when they're turned on. So if you look at this side, the high voltage red coming in, because these FETs are off, yeah, we shouldn't have a connection to the red here. No connection, yeah, from the high voltage. But if you look at the low voltage coming in via the diode, and depending if I've got it the right way round, just depending if I've got the polarity the right way round, from the violet one we should see the diode. Not that way, try the other way. Makes sense it's the other way, because this is positive, yeah. There's your diode, okay. So effectively, this wire either gets 88 or 44 volts, depending if these are turned on or off, okay. So look at the negative side. So the blue wire, this is negative, so let's put the black in here, because the diode should be the other way around. diode junction, yeah? And if we go from the high voltage, that's actually low voltage negative, yeah? Diode junction to the black wire. And if we go to here, we should have no connection. But we do. And the reason we have a connection is because we've got a short. And we know we've got a short, these. So this here is these. Yeah? On your amplifier board coming in, down here, let's see if we can see them clearly for you. We will find the plus and minus, yeah? They are. One's, they're here somewhere, I've seen them. Yeah, minus voltage black, and the red one, plus voltage red here, yeah? You probably can't see, it's there, plus voltage red, yeah? Coming in. So that's your 2 voltages, and then the green is your 0 volts. Output here to your speaker. The only other wire is this yellow wire, yeah, which says sense, and that connects to here. So this will be sensing the amplitude of the output, yeah? This yellow wire will be sensing the amplitude of the output, and I think we'll find that actually goes to the speaker, the output speaker. Okay, it doesn't go directly, but it will one way or another get to there via a bit of circuitry on here, yeah? That yellow wire is sensing the amplitude of the output and switching these on or off between the 44 and 88, and that's how it actually works, yeah? So what have we got? Chances are the amplifier's okay. With the fault on here, effectively what you've got a minus 88 all the time, yeah, and the other side switching between 44 and 88, depending on the amplitude of the output, which is probably why the guy said to me one of the amplitudes was going sort of woof, woof, woof. That's probably what he means by that, yeah? So we've got an imbalance in the voltages. So the negative one is always on 88, and the positive side is always switching between the two, yeah? That probably explains why the red light was flashing on the mixer as well, on the peak, because it was above, effectively, the amount of amplitude that the 44 volts could handle. Why I got no sound on either at the moment, I don't know. That might have been something else, because he told me this rum fum fum. I think I had some setting wrong on the mixer, which is why I had no sound at all. So I don't think there'll be any damage to this, because both sides are designed to handle 88 volts or 44. So I don't think we'll have a faulty amplifier. We've got a faulty MOSFET board, basically, yeah. And I'm pretty sure these are MOSFETs. They're probably all MOSFETs. So what I'm going to do is, first of all, let's just check what the devices actually are. And then secondly, let's unsolder these. And then have a look further down the board if we can see any shorts. There's no point me looking while these are in, because with this short, I'll probably miss something else, yeah. But there isn't much else. There's only another transistor here and a little one here. And the same to the side, one there and one there. Apart from those, we can unsolder them and check them. The rest is just diodes and resistors. We can check all that in circuit quite easily, yeah. So let's have a quick look and see what we actually have here, these devices. I'll make a, I don't need to make a note of the numbers, I can read them off the devices. Okay, let's go over to, let's go on Tinternet. Go on Tinternet and see what we actually have here. Okay, so on this is the one which is doing the switching of the voltage. Yeah, we have MJ15004, yeah, and 3, 15003, 15004. Let's see what it is. $20 amp power transistor, complementary silicon. Looks like it's actually is a bipolar transistor. You can give me some data? Give me a data sheet. If the site doesn't want to work, I can go to the other one. Just, yeah, making sure I hadn't paused the video then, actually. Oh, alright. If you want to be like that about it. All transistors. Sorry guys, I seem to have a problem with the internet. Just give me a moment to let me just sort that out first. Oh, did it just come up there? Yeah, it did. Okay, all transistors. Let's have a look. So we have MJ15003. MJ15003. It's a bipolar junction transistor. It says there BJT, yeah. Will it give us a data sheet? Oh, stupid adverts, go away. Go away. Don't you think the internet is getting really, really annoying these days? There's continuous advertising. NPN transistor, yeah, NPN silicon, 200 watt, okay, 140 volts, 20 amp. Let's look at the other one then. So that's MJ15003, MJ15004. So this would be a PMP, you would imagine, and the same sort of ratings, 20 amp and such like. Yeah. Go away. 15004. Yeah, 200 watt, 140 volt, 20 amp, PMP. So it's a complementary device. Yeah, that's those two. So they are transistors. And then the ones on the amplifier board, MJ15022. Go back one, MJ15022. 15022. Search. NPN silicon. So see, higher voltage, yeah. 16 amp. That's one of them, yeah. And then the other one, this is the NPN. So the other one's complementary. You expect it to be PMP, which is the 1, 2, 3, I believe. Yeah. It says it's yeah, 023. Yeah, so that's the PMP, 350 volts. So you can see the same ratings, just PMP. So that's what the devices actually are. Now let's desolder these two that are short circuit and see if we can determine if we actually need to do anything else. Let's get the soldering iron ready. Okay, so I've turned on the vacuum desoldering tool because I might well need it for this, but let's see if we can get these out. Yeah, this side. So we can get these out just using some flux and solder braid. Yeah, let's try that first and see. Let's get some flux on here. This is a bit tricky to dispense this one. Let's have a go. First of all, I think I'll add some leaded solder to help it desolder, yeah, reduce the melting point. So let's there we go. See if we can desolder these. I think we might have that one. I think that's looking pretty good to me. So just chop off that bit of braid. I'll try and get some flux on the other one. I'll try using a bit of the rosin flux, seeing as it's I've ordered some more of that liquidy flux, but it doesn't seem to be working very well. What's happened to my camera? I don't know how long that camera's been frozen. Obviously for some time. Sorry about that. At least you can see the main one. So yeah, let's just get a bit of this sort of flux. Just melt a channel in there with the iron and dip the braid into the flux. Yeah, that's it. That's well fluxed. It's well fluxed. I think that's got that one. Go with the other ones. Yeah. Can we do this with braid without using the vacuum desolderer? Let's see. Yep, that looks pretty good. I'll just see if the if I've actually managed to desolder these. If I can move the legs a little bit, I know that they're actually free. Yeah, that one's free. Yeah, that one's free now. See, it fell out. Yeah, they both fell out. Okay. So here's our transistors, which are clearly short circuit. We'll just get the meter anyway. Okay. It says they're clearly short circuit, and that one isn't. Well, that's strange. That's strange, because they're not short. Something's short somewhere on here. Heat sinks fell off. Okay. Okay. That's not short. What is short? Short circuit di no, these diodes are okay. So something's short. Come down to this other transistor down here. That's interesting. That 22 ohms. Short. Yeah, there's a short on this board somewhere. Where does that go to? I have a quick poke around, save you guys waiting. Just see what if I see what the actual short is. Okay, guys, I just had a quick look around. It's quite clear if we go from the negative HV that we do have a short, yeah, and it's still there without the transistors in. So I thought, well, what's short, yeah? And I thought, well, there's another transistor down here. So I looked at this and there was no short there, yeah? I'm reading a resistance, but it's not a short. But down here also was a diode. And that diode reads short. This is a low value resistance, not reading enough short anyway. That diode's reading short. Yeah, it's reading slightly higher. I'm just thinking the resistor's close to the diode, but I don't think the resistor's connected. No, it's not connected across the diode. So, which wouldn't make sense to have a very low value resistor across the diodes. So we have a diode down here, and that appears to be short. So we need to remove that, and then if that hasn't found the short, we need to have a look to see what else can be short. So that diode's connected from here to here, yeah. So let's take that out and then see what happens then. Yeah, there to there. I can't get any flux out of that thing. Okay, no worries. Let's use the other stuff. So, this is one end of it. Is this like a ghetto mod, like an afterthought to that capacitor there? Think, oh, I don't know, perhaps we should have put a capacitor here. Let's just make sure I can see which end is the diode is which. Is it marked on the board? Can't say for sure, so let's just find a black marker pen. That ends the stripe, yeah. I mean, I might be able to see once I take the thing off the board, but just to be, certain that we know which way round it goes. Yeah, we could always take the other one apart and look on that, but this is less hassle, isn't it, really? Let's make life easy. Easier. Yeah. Okay. Get this off here. I mean, if you're looking for, a short, the main places to look really is, power transistors, big diodes anyway. Capacitors can be short, especially the surface mount ones, the little chunky square ones. MLCCs, they tend to go short. I think that's actually, yeah, it's fell out the board, yeah. So we can just clean the hole. Yeah, the hole's clean now. So is it short circuit? Shall we have a look? Yep. So there's our short. Yeah. It's a bloody hot. It's a bloody hot. That's what that is. It's a bloody hot. It's 1N5404. I think I might have those. 1N5404. Let's see. I have something similar to that. 1N5404. What is it? Let's have a look, see what it is. 1N5404. I think it's a 2 amp or something like that. N5404. What is it? Plastic silicon rectifier. What rating are you? 1N5404. Three amp. 400 volt 3 amps, yeah. Let's see if I can find a suitable replacement for that. Okay, so I couldn't actually find one of those. I've got lots of Schottky diodes around the same sort of current and voltage rating, but I'm mindful of this sort of thing to really try and replace this with the correct part. I know audio amplifiers can be a bit finicky. I mean, I know this is not the amplifier board, but I am very tempted to replace that with the same part number. So I'll speak to the guy who owns this and ask him if he doesn't mind just waiting a little bit. Depending on how long he wants to wait, I can either order from AliExpress, or I can order from Mouse or somewhere, which are going to be considerably more expensive but quicker, or eBay. Okay guys, so we'll leave that at that, and I will post again when one moment. Hi, sorry guys, but it was the wife, so I have to answer that one. Yeah. So I'll speak to the owner, look to order some parts for this. I'm pretty confident that there's probably nothing else wrong. I mean, I can take this transistor out and this transistor on the same channel and just check them. I'll have a yeah, go on, you got a few more minutes. Let's see if I can see any shorts. If I can't see any shorts, the shorts gone. No, there's no shorts there. I don't know what this device is. Doesn't really read anything, so I'll take it out. This is a little transistor. I'll take that out as well and I'll check these. But that's easy to do. Stick them on the component analyzer and just have a look to see if they're okay. Yeah, We can check all the diodes on this side just to see if the, they effectively read like diodes, like that one doesn't, for instance. So I'm going to go over this board now and just effectively, I'm not on diode mode, that's why. Now it might look like diodes. Yeah, that one does. That one does. I still have a short ear, so I need to look at that. That's all the diodes. I have a short circuit diode here as well. So basically now this is just a matter of just going through all the semiconductor devices, looking for short circuits. The same with the 2 transistors, just take them off the board and test them off the board if anything looks suspect. If they don't look suspect, I think, yeah, that's okay by the looks of it. Is this the other one? Yeah, there's the 2. I'm going to take them out. I'm going to take them out just to be absolutely sure, because you want to make sure with this sort of job that you've replaced, you've tested all the various components, because when you put it back together, you don't want the same thing blowing up again. Yeah, certainly there's a short here. Okay, so that's what I'll do. I think that's enough for this video though. So yeah, what I'm going to do now. I'm going to check the rest of the components, order the parts, and when I get everything here, we'll just finish the job off. Another quick video, you can see it's all working, and then yeah, I think that's another one which will be successfully repaired. See you soon, guys.